I'm exploring the fascinating world of plants, from the most bizarre to the most beautiful. With new techniques and in 3D, we can unravel their deepest secrets. We can move from our time scale to theirs. We can see how they struggle with one another, how they get help from some animals, but have to battle with others and survive against the odds. And we can watch all these dramas taking place in a way that is impossible in the wild in one unique institution. The Royal Botanic Gardens at Kew. In this living laboratory, we can discover plants' most extreme adaptations for survival. And we can glimpse Kew's tiny weapons in the battle to protect the future of all plants, seeds. Ever since plants first moved out of water and colonized the land, they've advanced into drier and drier places and evolved specialist adaptations in order that they can do so. Today, deserts cover about 1/3 of the land surface of the Earth, and they're spreading rapidly. But some plants have developed some truly extraordinary strategies to enable them to survive in the driest of places. In deserts where water is scarce, one major strategy is to remain passive during the day when temperatures soar and only become active in the cool of the night. This desert, in Kew's Princess of Wales Conservatory, contains plants from arid regions all around the world. And in midsummer, one plant here does something truly astonishing. Don't be deceived by the shriveled, untidy appearance of this cactus. It is in fact one of the most remarkable members of the cactus family. It's called Hyla cereus, the queen of the night. It lives in Mexico, where during the summer at midday, the temperatures can reach a crippling 50 degrees centigrade. So during the day, it doesn't do much. But once a year, and for one night only, it becomes a thing of astounding beauty. The flowers usually open on a night of the full moon, and as they do so, they give off a smell which attracts night-flying animals, large and small. And as they get nearer, they can see the great white flowers bright in the light of the full moon, and they go to them to sip the nectar, and in doing so, pollinate the cactus. It might seem strange, even risky, for a plant to restrict its flowering to just one night of the year. But this strategy works for Hylocereus. Its flowers are the biggest and brightest around, and they offer its pollinators a nectar bonanza. Bats. With the aid of technology, we can imagine them thousands of miles from their natural habitat here in Kew. Bats pollinate all kinds of cacti. In springtime in South American deserts, there is always a cactus of one kind or another in bloom. A multitude of species compete for the attentions of nocturnal pollinators using bright petals and powerful scent. The sweetest perfumes attract insects. But flowers that are pollinated by bats are rather more pungent. They give off the stench of rotten fruit. To nectar-feeding bats, that smell is irresistible. They fly from cactus to cactus, sipping up the nectar. Each bat can consume 1.5 times its body weight of nectar in a single night. Very tall columnar species produce flowers right at the very top of their stems, where they're easily smelt and seen and easily reached. Some provide additional facilities. Espastoa guanteri from Bolivia sprouts a landing strip beneath its flowers, a pad of fur on which the bats can alight without damaging their wings on the spines. But in Mexico, bats and cacti have an even more extraordinary relationship. Each year, bats migrate across 1,000 miles of desert from central Mexico to Arizona. Pregnant females, 100,000 of them, are on their way to special maternity caves in the north where they will give birth to their young. The bats get all the nectar they need to sustain their journey, and in return, they pollinate the cacti. This annual bat migration coincides exactly with the blooming of the night-flowering cacti. So the bats can fly along a nectar corridor. And so can cross a patch of desert that otherwise and at other times would be impassable to them. By the time the bats return with their pups, the cacti are able once again to provide the bats with food, this time their fruits. The bats carry with them in their stomachs the fruit and the seed it contains, and in due course they deposit those seeds with a nice little packet of fertilizer farther down the corridor. So the corridors are self-perpetuating. The bats, in effect, are cactus farmers. Perhaps the most extraordinary thing about these night-blooming cacti is that just a few hours after the flowers burst open, they begin to close. By the time the sun appears, they have already wilted and died. This is all part of their survival strategy. The closed petals form a protective shield around the newly pollinated seeds, locking vital moisture inside. The light of a new day reveals the bizarre nature of dry zone plants. These are surely some of the oddest looking species there are, and their strange shapes are a direct response to the harsh conditions. These plants must stay in the baking sun to collect the light they need, but they must also retain their moisture. Many do that by turning either their green stems or their waxy leaves into reservoirs. This extraordinary cactus from Mexico is covered in thick white hair. It's called the old man. This fur not only provides shade, but restricts the circulation of air around the surface of the stem, and that reduces water loss. In even hotter and drier climates, some plants avoid the sun altogether. This is Fenestraria, the window plant. It grows in the Kalahari Desert, with most of its body buried beneath the soil. Only the blunt, flattened tips of its leaves are exposed. Each contains tiny lenses which transmit the sunlight down through the vertical leaf onto its green photosynthesizing cells. Some desert plants that live in exceptionally hot, dry conditions take even more drastic measures. Leaves are very thin and have a large surface area, so they lose a lot of moisture in heat, and many desert plants have done without them altogether. Instead, the valuable green pigment develops in the stems, and desert stems are often very thick and swollen, and that enables a plant to store water in them. Not only that, but some desert plants have pleats in these stems, so that when there is a sudden rainstorm, those ridges can suck up all the moisture while it's there and expand in order to hold it. The stems of some of these species swell to such a degree that they become almost spherical. A sphere has a minimum surface area for any given volume, and that enables the plant to hold as much water as possible. This one is Copiapoa from northern Chile, where it never rains at all. But in fact, it doesn't need it. Under a microscope, you can see why. There are thousands of tiny, jagged structures on which the morning dew condenses so that the plant can collect it. But the ultimate is this plant.
It's hidden between these light-coloured pebbles. Blossfeldia from Argentina.
This is the only flowering plant that can withstand total desiccation for months on end, and then with a shower of rain or a little bit of water, it comes to life and produces a tiny little flower.
This ability to wait for the right conditions is the trump card that enables many plants to survive in the dry zone. In many deserts, plants must endure months, sometimes years, of drought. They do it by slowing down their metabolism and going into a state of virtual dormancy. But when rains finally arrive, plants like these suddenly come to life. Their dried-out tissues absorb water like sponges. And once expanded, they use the moisture to grow. This primitive, rootless plant from the Chihuahua Desert in Mexico is a spike moss, Selaginella. It's also called the resurrection plant because of its ability to seemingly come back from the dead. Rain starts a complex biochemical change in its cells that enables it to ramp up its metabolism and grow very quickly while it can. But the most spectacular consequence of rain in the desert is an explosion of colour. Desert flowers are as colourful as any in the world. They have to attract pollinators quickly before the deserts dry out once again. But moisture in the soil can evaporate almost as quickly as it arrives, and after a brief bloom, they die.
Desert plants can only grow when the conditions are right, and that may be only for a few short periods in the year. So many desert plants take a long time to reach full size. That agave there, for example, is over 40 years old. But during that time, it has manufactured food and gathered water and stored them in its great fat leaves. But it's not yet adult. This one is. This agave has started to withdraw that water and food from its leaves, so now they're beginning to crumple and wilt. And it uses that food to fuel the growth of this huge mast-like stem that grows from its center and will carry the flowers. And it reaches its full height at extraordinary speed.
It can grow by 1/4 of a metre every day. It reaches such a height that here in Kew's glasshouse, panes have to be removed from the roof to let it through. This infrequency of flowering has given this species of agave a nickname, the century plant.
So, why does the agave produce this huge, tall mast? Well, some plants are pollinated by insects, and you attract insects with smell. But this plant is pollinated by birds, hummingbirds, and birds have little or no sense of smell. To attract them, you have to exploit their very sharp sight. You have to produce flowers that are very bright and put them right at the top of a prominent, tall mast.
Growing at such a rate demands considerable effort. For the agave, it's terminal.
The act of producing that mast is the last act in this plant's life. Having done it and been pollinated, it dies.
Thanks to their extraordinary survival strategies, desert plants are able to thrive in places where others would die. But that makes them the focus of much unwanted attention.
There's a downside to success for a desert plant. The more water it stores, the more tempting it is for a thirsty animal to try and steal it. So desert plants have to have good defenses.
The techniques they use can tell us something about the herbivores that try to feed on them. This Echinopsis from Argentina develops long, strong spines as a defense against large grazing animals, llamas. But such defenses also provide hiding places where an insect or a spider can keep out of harm's way.
There are other ways in which a plant